Hi, very good morning to everyone. My name is Nagraj S. Kumar Goppa, Computer Science Department. Today I'm going to explain you about the basic concepts of object-oriented programming, and it includes objects and classes, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, and finally message communication. Before going to explain you about all these topics of object oriented programming, let me tell you about what exactly object oriented is. So it is an approach that provides a way of modularizing programs by creating partitioned memory area for both data and functions that can be used as templates for creating copies of such modules on demand. And its major objective is to eliminate some of the flaws encountered in a procedural oriented approach. So other than this, it has also some other features like it emphasizes on data rather than procedure, and programs are divided into what are known as objects. Also, data is hidden and cannot be accessed by any external functions, and new data and methods can be easily added whenever necessary. And this object oriented system follows bottom up approach in program design. That is what the object oriented is. So let us begin with all the basic concepts of this object oriented system. They are objects and classes, data abstraction and encapsulation, then inheritance, polymorphism, dynamic binding, message communication. These are the major pillars of this object oriented programming system, or you can call them as basic building blocks of this object oriented programming. And these forms the heart of Java programming, the heart of Java programming. So let us begin with objects and classes. So objects are nothing but basic runtime entities in object-oriented system, and objects contain data and code to manipulate that data. These objects are basic runtime entities. That is nothing but it is related to the real world. And if you want to give examples of objects, I'll be considering examples of objects: a person, a place, a bank account, a table of data, or any other thing that a program may handle it. Then if you consider an example for object a person, then it will be it will be having some of the attributes like name, age, date of birth, color, salary, and tax. Because each and every object you create, each and every object you use in Java programming, it will be work around the basic attributes of that particular object. Here I'm considering an object as a person. This particular object will be having attributes like name, age, date of birth, color, salary, and tax. Again, in that there are two parts: these name, age, date of birth, color. All these four are nothing but data members of this particular object, and salary and tax are nothing but member methods. That is nothing but this functionality of this particular object person, and this indicates the data which are present under this object. And a class is nothing but it can be defined as a template, or it is a blueprint that describes the behavior and state of an object. Once a class has defined, you can create any number of objects of that class type. That is nothing but a class is nothing but we are putting object data members as well as member methods of an object and together at one place, and we are making it as a class. That is nothing but we are wrapping the data in the single unit. That is nothing but a class. So programmatically, how to create a class, how to create an object, we'll see programmatically in further videos. So this is what objects and classes. So we'll move to the further topics. That is, the next topic is data abstraction and encapsulation. Data abstraction is nothing but the act of representing essential features without including the background details or explanations. That is nothing but we will be showing the essential part of a particular thing and we will be hiding the internal implementation of that particular object. And data abstraction provides insulation of data from direct access by the program is called as data hiding. That is nothing but what I explained to you people just now. It will be providing an insulation for the data of that particular object from direct access by the program. That is what data hiding. Then the wrapping up of data and methods into a single unit is known as encapsulation. That is nothing but a class. A class is the best example for this encapsulation. That is nothing but we are putting the data and methods into a single unit and placing them in a class. That is nothing but an encapsulation. Again, if you want to consider an example for this data abstraction, I'm taking here an example, manufacturing of a vehicle and a person. If you take this manufacturing of a vehicle for abstraction, that is nothing but whenever you consider a vehicle, that is nothing but it will be having, user will be knowing only the color of that particular vehicle, the number of wheels for that vehicle, and how many gears are present for that vehicle, but we'll be never knowing that how it is implemented, how gear system works internally. That is what data abstraction. We are showing only essential part outside world and hiding the internal implementation of that particular thing or particular object vehicle here. And one more example about data abstraction is person. I'm considering data abstraction example as a person. That is nothing but a person may act differently in different situations. If you go to your offices, if you go to your workplace, you will be behaving in a different way. When you come back to your home, you'll be behaving differently. Then whenever you go to outside for any party, again in such situation you'll be behaving differently. That is what data abstraction is and encapsulation is. So the next topic is inheritance. The next topic is inheritance. That is nothing but it is a mechanism of acquiring the properties of one class to another class, and also it ensures reusability, and it has is a relationship. That is nothing but mechanism of acquiring the properties of one class to another class. That is nothing but we are getting the properties of one class to another class. That is nothing but we are creating a class by the name animals, and these animals class properties are inherited by a mammal, reptile. That is nothing but a reptile is a type of animals, mammal is also a type of animals. That is nothing but mammal will be inheriting the properties of animals, as well as a reptile will be inheriting the properties of animals. And ensures reusability. That is nothing but whatever the functionalities you have declared here, you have defined here, you'll be reusing them in its subclasses mammals and reptiles. And also mammal is a animal, reptile is a animal. That is nothing but mammal and animal. In between these there is a relationship, that is nothing but is a relationship.